Hello everyone and welcome to this video. So in this video, what we're going to do today is we're going to be moving on to the next step of Scikit-Learn, and that is to learn how to evaluate your machine learning model. So this means we're going to be learning how to work out if our machine learning model's predictions are good or not. So let's start. So this is where we left off last time. We actually learned how to make predictions for our machine learning model. So what we did is we did it on classification and regression. So what we're going to do today is we are going to learn how to evaluate a machine learning model. So I'm just going to write evaluating a machine learning model. So there are actually three ways to evaluate a Scikit-Learn model / estimator, because remember, you can also call it a estimator as well. So number one is to use the estimator score method. So estimator score method. And then the next one is we can actually use the scoring parameter. So we have not been through this, it's quite a new one. And then number three is we have covered this a tiny bit. So this one is problem specific metric functions. So we have gone through this a little bit, but we haven't fully dived into it yet. So now I'm just going to put my little heading, and this I'm going to put my subtitle. So 4.1, we're going to be learning about evaluating a model with the normal score method. So first we're going to create a classification model. So we're going to go from sklearn.ensemble import random forest classifier. So we're going to be using it because we're going to be doing classification first. So I'm going to go np.random.seed. As always, we're going to set it to 42. And then we're going to go x is equal to heart disease dot drop. We are going to drop the target column, and we are going to put in axis is equal to 1 to let it know that it's a column. And then we're going to say y is equal to heart disease, and then we simply have to index to the column our target column. Then we have to split it into training and test data. So x train, x test, y train, and y test is equal to train, test, and split. Train, test, split, and then we're going to pass in x. We're going to pass in, so remember it's a capital X actually. So we're going to pass in capital X, then we're going to pass in y, and then we're going to pass in the test size. So this is basically how much of the whole data set do you want to be for the test data. So now what we're going to do is we're going to instantiate and fit our model. So we're going to do this in one line like we did in the previous video. So CLF is equal to random forest classifier, and then we're going to put dot fit. So we can do that nice and easily in one line. And in our dot fit, we want to pass in x train and y train. So I'm going to run that. So it has fitted right now. So the first thing you want to do is we're going to use clf.score. So we're going to say clf.score, and we're just going to score it on the training data first to see what we get. So x train, y train. So we have gotten 1, which basically means 100%, because we have gotten 1 because we've already fitted it to x train and y train. So it's already found the patterns in the training data. And if you just test it again on the training data, it will obviously just get full marks. So now we're going to do it on the testing data. So clf.score, we're going to go x test and y test. So remember, it has never seen this one before. So this one has actually just gotten about 20% less, I suppose. It's gotten 20% less, but that's not actually a bad score. This is actually really good for a machine learning model. If it was to get 1, then that means that you have either not trained it properly, or you have accidentally given it a sneaky peek of the test data. So now that we have done that, what I'm just going to do is I'm going to press Shift Tab to see what it means. So here it's saying return the mean accuracy on the given test station labels. So keep this in mind, because we're going to be comparing this meaning to to the regression model as well. So in Markdown now here, I'm going to write, let's do the same with a regression model. Okay, so we're going. So that is what we're going to write here. Hold on, and then enter. So we're not going to be writing that all over again. I think we've written it enough. So we're just going to copy this because we've already written it. So yeah, so here we go. We have written it here. I'm going to take away this make prediction section because that is not what we're learning today. We are just learning how to instantiate and fit the model. How to score the model. So we did that in one line. So I'm going to go model.score. We're just going to score on x test and y test. So yeah, so we've gotten just a little bit higher, but that doesn't mean there's anything bad about that, but because it is just a different data set, and they're just predicting a number, so so that is probably why they got a high score. So if we look at the meaning of this, of a score for a regression model, it says return the coefficient of determination r squared of the prediction. So it returns the coefficient of determination r squared. And then here what it says is it actually returns the mean accuracy. So both of these have two different meanings, and one of them is quite confusing. It says the coefficient of r squared. So it would be great. So it's great if you just searched it up and found out, because then you would have that ready for the next video. So in the next video, what we're going to be doing is we are going to be looking at the scoring parameter in because that is the next way to evaluate a Scikit-Learn model / estimator. So if you like this video, please like and subscribe. That would really help. And if you have any doubts, please comment them in the comment section below and I will answer them. And yeah, I guess that's the end of this video. Bye.